Next up into the Shark Tank, a very creative and innovative way to tell your time.
Hi Sharks, I'm Cody.
And I'm Logan.
And we're a small startup in the heart of Silicon Valley asking for a small $750 million for 2.4% of our company.
I know what you're thinking, Sharks. What would such a small amount of money contribute to anything worth investing?
I give you the Cobby Lane contraption clock. Now I know what you're thinking. What is this used for? Simple. It's a clock.
Specifically, a 1-minute clock.
The clock starts with the pointer aiming at the top, like this. And it will return a full minute basically after completing a full circumference, like this.
The radius of the arms is exactly 1.3 centimeters.
The equation of the circumference being 2 pi r, we calculated that it would be exactly 8.16 centimeters.
No, we're not asking about that. We're asking about...
Wondering the angular velocity. Precisely. I am too. The angular velocity is very similar to vertical velocity.
So the form for vertical velocity is right here. It's distance over time. But because we're going in a circle, we're going to use angular velocity, which is 2 pi r over t.
Which is basically the circumference over the time of one resolution.
Plugging in the numbers, we would get 8.16 divided by 60. This is the circumference divided by the time, which gives us 0.136 centimeters per second.
Okay, that's cool, but
The angular acceleration, we got some good news for you.
Since the clock is constantly spinning at a constant velocity, there is no acceleration. So that can just remain a big fat zero.
Alright, but what about the...
About the centripetal force. We knew you were going to ask that. Okay.
Centripetal force is a tangential speed squared divided by the radius. And the tangential speed is equivalent to the angular speed multiplied by the radius, which is 1.3 times 0.136, which should equal 0.1768 meters squared per second.
And with that, we can square 0.1768 by 1.3, giving us 0.024.
Are you idiots even listening? We're asking about the sail.
Here is the funny part though. So using the moment of inertia, our arm is basically a rod. And basically the equation for moment of inertia for a rod is 1/12 times mass times length squared. And fun fact, the arms weigh 0.23 kilograms, and the radius could also be the length of the arms. And putting these all in, we would get exactly 0.032 kilograms times meters squared per second.
Okay, Sharks, now let's find the torque. Now the equation for torque is the moment of inertia times acceleration. Now, if we can remember to our previous equations, our actual angular acceleration is just 0 because we have a constant velocity. And anything times 0 equals 0, meaning our torque is 0.
It's basic physics, really. It's just that. It's really just basic calculations in physics.
Right.
Alright, enough! We want to know what it's used for.
It's a 1-minute timer.
It tells the time.
And how is it useful?
Because we thought it would be cool.
Yeah, it'd be cool because it's a clock and it tells the time.
Guess what does that too? My watch! This might just be the stupidest idea ever. You con artists. Why, of all things, do you make this? And you expected us to give you $750 million for this? I can buy a car for 100 times less than that. And on the dashboard is a clock, you useless pieces of. Can you at least give us a challenge that you faced when making this?
I guess finding the calculations was like the hardest part because like we had to make sure it was like right. And it's funny.
Yeah.
You're telling me that you spent 90% of your time on the calculations rather than the actual product? What about the sales? This might just be the worst pitch of all time. You are not getting any money. Give up now. This is poo-poo on a stick. We are all out. Thank you for coming in. Wouldn't want to be you.
Thank you for your time, Sharks.